Okay, hello students of class 8th, and we are learning physics and we are doing our chapter 2 physical quantities and measurement, and we'll continue our chapter. And so today's our topic is relative density. Okay, last time we learned about how to find density of regular and irregular solid and also density of liquid. So the next topic we have relative density, and it is also important topic. Okay, relative density means here we are comparing the density of substances with another quantity or another matter or another substance. So it's that's why it's called relative, because there are comparison of two densities. Okay, so this relative density is also known as specific gravity. When we compare it with density of water, so we learn how. So this relative density is equals to density of substance upon density of water at 4 degrees Celsius. Okay, so and density of water at 4 degrees Celsius is always 1 gram per centimeter cube or 1000 kg per meter cube. So relative density is the ratio of two densities, density of substance with substance whose relative densities we are finding. Okay, so density of substance upon density of water at 4 degrees Celsius, and density of water at 4 degrees Celsius is always constant, 1 gram per centimeter cube, or we can say 1000 kg per meter cube. This is the density of water at 4 degrees Celsius, and this is the formula for relative density. And we know that density equals to mass upon volume. So density of substance will be mass of substance upon volume of substance, and density of water will be mass of water at 4 degrees Celsius and volume of water. So if these two are same, means volume of substance and volume of water is same, then relative density will be equals to mass of substance upon mass of water. Okay, in that case, if they are same volume, then they will be cancel out. If volume of substance and volume of water is same, then relative density will be mass of substance upon mass of water. So this is also the formula for relative density if the volume is same. Okay, mass of water at 4 degrees Celsius. Okay, they have also given here the same thing. If volumes are equal, then relative density equals to mass of substance upon mass of water at 4 degrees Celsius. And relative density do not have any SI unit, because it is the ratio of two densities, and ratio of two density means, so density of substance is SI unit will be kg per meter cube, and also density of water is SI unit will be kg per meter cube. So this will be cancelled, so it do not have any SI unit. Okay, also here in this case SI unit of mass is kg, and also mass of water is SI unit will be kg, so they will get cancelled. So it has no SI unit, it is just a pure number. And with this formula we can find the density of substance also. Means density of substance, how can we find? So we know that relative density equals to density of substance upon density of water. So if we are finding density of substance, so this will be multiplied here. So density of substance will be relative density into the density of water at 4 degrees Celsius. Okay, as they have given here, that density of substance equal to relative density of substance into 1 gram per centimeter cube, and this is density of water at 4 degrees Celsius, or 1000 kg per meter cube, and this is density of water at 4 degrees Celsius. Okay, this is the method for finding density of substance by using the formula for the formula of relative density. Okay, and then the next topic we have determination of relative density of liquid. How to find relative density of liquid? Okay, so for this we have a apparatus which is called density bottle, relative density bottle, or pycnometer, and or we can also say this gravity specific gravity bottle. Okay, and the structure of this bottle is like this. So here what we will do, we place liquid here in this. They come in different sizes, suppose 25 ml, 30 50 ml, like this. So it is easy to find volume by this pycnometer, means we'll pour out liquid here, and then we'll place this capillary tube. So this capillary tube has a hole, and the excess, if we fill water up to here, so that excess water will come out from this capillary tube, and we will got the exact volume of that liquid. Okay, so how we find the relative density? So here you can first of all we have to take mass of the empty bottle. So we'll measure the mass of this empty bottle, then we will fill this bottle with water, and then we'll take the mass of bottle and water, so that will be M2. We can take with the help of weighing machine, beam balance or physical balance or electronic balance. Then what we'll do, we'll pour out the water, then we'll clean the density bottle, and then we'll add the liquid whose relative density we are finding, and then we'll take out the mass of bottle and liquid, and suppose that is M3. So M1 is mass of empty bottle, M2 is mass of bottle plus distilled water, and M3 is mass of bottle plus liquid. And then if we are finding only mass of distilled water, so we'll minus out M2 minus M1, so we'll got mass of distilled water. Okay, because this will be cancelled, so M2 minus M1, so we'll got mass of distilled water. And if we are finding only mass of liquid, so that will be M3 minus M1. We'll minus out this mass of empty bottle to find out mass of liquid. Okay, and then if we'll put that in formula of relative density, this formula. So relative density of that liquid will be mass of substance. So mass of substance here is M3 minus M1, and mass of water, so mass of water will be M2 minus M1. Okay, as it is written here also. So mass of liquid is M3 minus M1, and mass of water is M2 minus M1. Okay, so we'll got relative density by this formula. And if we are finding density also, so we'll multiply it by density of water, because this is the relative density, and multiplied by density of water we got density of that liquid. Okay, so this is the way of finding relative density of liquid, and this is very easy. Just read it at once by yourself and you will understand it more nicely. Okay, and then this hydrometer, so this is also used to find density of liquid, relative density of liquid, generally for acid batteries. Okay, so this structure is like this. So generally what we do, we take a measuring cylinder or beaker, okay, and then we fill that with that liquid whose relative density we are going to find, and then we place this hydrometer in that measuring cylinder or beaker. Okay, and then we twist it little, and then we just leave it, and then at a point this hydrometer came rise up to the surface of liquid. So we'll note out that point, and that will be the relative density of that liquid. Okay, as you can see here, the liquid to test is poured in a graduated cylinder or a tall jar, and the hydrometer is lowered into the liquid until it floats freely. The point at which the surface of the liquid touches the stem of the hydrometer is noted, and the value of scale is read. Okay, so when it became free, it raised little up to the surface of liquid, that is noted, and that is the relative density of that liquid. Okay, so it has a graduated scale, means here we will measure out as the scale is in the case of measuring cylinder or beaker. So this is used for measurement, and this is a hollow glass body, and there is a weight to keep the this hydrometer upright, means straight, so it will not tilt here and there. Okay, so this is used to find relative density of liquid. And then we have a device also, a special hydrometer, that is called lactometer, which is used to find purity of milk. Okay, and it check the density of milk. So if it's in that scale, the purity of milk in that scale, it means the milk is pure. So we can check the density of milk, and then finally we can check the milk is pure or not. Okay, and it is also used to use breweries to estimate the content of alcohol. Okay, so this was the concept of relative density and how to find the relative density of liquid. And then we have some numericals, they are formula based. Okay, and these numericals we will solve later on. Okay, and you can practice them yourself, and if you have any difficulty, just note them down, and you can ask when school will reopen, or you can come anytime in school if you have any queries to ask the questions. Okay, next topic we will do in next video. Okay, up to then read this concept, understand them, and if you have any difficulty, I am again saying that note down them, and you can ask in school, or you can come at school, or you can ask when school will reopen. Okay, so it's your choice. So we will see you in next video. Up to then, God bless you all.